This is not a normal tire. It stands taller than a human. It weighs more than a car. And it carries machines that move mountains. Today, we go inside the extreme world of giant mining truck tire manufacturing. Welcome back to Tire Industry Insider. In this episode, we explore how the largest tires on Earth are built. These are the tires used on ultra-class mining trucks, vehicles so massive they can haul over 400 tons of rock in a single load. And without these tires, modern mining would stop. A single giant mining tire can measure over 4 meters tall. That's taller than most houses. It can weigh more than 5,000 kilograms. Each tire costs tens of thousands of dollars. And yet, it must survive extreme heat, razor-sharp rocks, unbelievable weight, 24-hour non-stop operation. Failure is not an option. Unlike passenger car tires, mining tires require specialized rubber compounds, natural rubber for flexibility, synthetic rubber for heat resistance. High strength, steel cables for reinforcement, carbon black to increase durability. The formula is carefully engineered to withstand brutal mining environments. Even slight changes in compound ratios can affect load capacity and lifespan. Precision begins at the molecular level. Inside giant industrial mixers, tons of rubber compound are blended under extreme pressure. The heat generated during mixing must be carefully controlled. To hot, the compound degrades. To cold, it won't bond properly later. Sensors monitor every second, because once the tire reaches full size, there's no room for internal weakness. Here's where mining tires become extraordinary. Multiple layers of thick steel cables are embedded inside the rubber. These steel belts form the skeleton of the tire. Each cable must be perfectly aligned. One misplacement could compromise the entire structure. Unlike standard tires, these steel reinforcements are massive and designed to handle hundreds of tons of pressure. This internal framework is what allows the tire to support the heaviest land vehicles on Earth. Surprisingly, many giant mining tires are still partially built by hand because automation at this size is incredibly complex. Skilled technicians layer inner liner, sidewall rubber, steel belts, massive tread blocks. Each layer is carefully pressed and adjusted. At this stage, the tire is enormous, but still soft. It is known as a green tire. Incomplete. Uncured. Waiting for transformation. Now comes one of the most intense stages. The green tire is placed into a colossal curing press. These molds are enormous. Heat reaches over 150 to 170 degrees Celsius. Pressure is applied evenly across the entire surface. This process can take several hours. During curing, the rubber chemically bonds, the tread pattern forms, the structure solidifies. What was once flexible becomes an ultra-durable industrial giant. When the mold opens, a finished mining tire is revealed. But the process is not over. The tire must cool slowly to prevent internal stress fractures. After cooling, inspection begins. Technicians check surface integrity, tread, accuracy, steel alignment, uniformity. Some facilities use X-ray scanning to inspect internal structures. Every tire must pass strict standards. Because in a remote mining site, replacing a failed tire can cost hundreds of thousands of dollars. Once approved, the tire must be transported. Due to its size, special equipment is required. Cranes lift it. Heavy-duty trailers move it from factory to remote mining operations around the world. Australia, Canada, Chile, South Africa. Wherever minerals are extracted, these tires are working. In the mines, temperatures soar. Loads reach hundreds of tons. Sharp rocks threaten sidewalls. The tire flexes constantly under crushing weight. And yet, it must perform day after day, month after month, because down-in-mine mining operations means millions in losses. From raw rubber to one of the largest engineered rubber products on Earth, this is how giant mining truck tires are. Made. Massive. Powerful. Built to move mountains. Subscribe to Tire Industry Insider for more inside access to the world's most extreme industrial machines.